Hi, this is Pure Chemistry, Chapter 15, Electrolysis, 2010-2019 TYS Topical. Okay, so for electrolysis, so for this question, potassium chloride has a melting point of over 700 degrees Celsius. Molten potassium chloride can be electrolyzed. So which means that this temperature here must be above 700 degrees Celsius. Okay, so remember, as you watch this video, make sure you annotate your questions. So okay, always annotate your questions as you are doing it. Molten potassium chloride heat. Okay, chlorine gas forms at the anode. So this one is molten. So molten, remember when you do electrolysis question, always list down the ions. Molten potassium chloride, you have K plus Cl minus. Okay, K plus Cl minus, and the chlorine gas will form at the anode, of course lah, because the N ion will be attracted to the anode. We might expect potassium metal to form at the cathode, but in practice, potassium is very soluble in molten potassium chloride. So which means that as potassium is as the K plus discharge at the cathode, okay, it will form K, right? Then immediately after that, it will dissolve in the molten potassium chloride. So which means that this part, potassium is very soluble. This part, this is actually a mixture of potassium ion as well as chloride ion. Okay, so this is actually a mixture at the cathode. A solution of potassium in molten potassium chloride form. Yeah, this is actually this part. Okay, K plus and Cl minus. This problem means that electrolysis cannot be used to extract potassium from potassium chloride. After that, because after that it will mix with the molten potassium chloride. The information contains an example of a compound and an example of the mixture. So the mixture would be solution of potassium in molten potassium chloride. So identify the compound as well as the mixture in the information. So the compound would be molten potassium chloride. And then the mixture would be solution of potassium in molten potassium chloride. Now, so for some of the questions, I'm not going to write down. I'm just going to say so that the video can be shorter. Yeah, otherwise the video will be very, very long if you wait for me, because I write very slow. Okay, explain the difference between a compound and a mixture. This question, basically you don't have to relate back to the context. This one is just a very general questions about the difference between compound and mixture, which is in chapter 4. So you can state any differences. There are actually altogether 4 differences. So just to recall, so these are the differences can be summarized in SPEC. So either one of these would be able to answer the question. So you can say the component in the mixture can be separated by physical methods, whereas for the compound, the elements can only be separated by chemical reaction. Okay, so any one of these. So take note to use terms like the constituent elements. Yeah. Okay, so properties are the same as those of its component or constituent elements. That means the elements that make up of it. So for the mixture, the properties is the same. But then for compound, the properties will be totally different from its constituent elements. So any one of these differences will be able to answer this question. Explain the difference between a compound and a mixture. So if you look at the answer actually look at the composition. Okay, compound contains a fixed composition of its elements, while the composition of constituents in a mixture varies. Okay, so this part it's about the composition, the last one. So SPEC, separation, properties, energy change, as well as composition. Four differences between mixture and compound. So I'm not going to write down. Okay, the electronic configuration of a potassium atom can be written as this. Okay, complete the table to show the electronic configuration of potassium ion. So, potassium ion, it must lose the valence electron. So become 288. And then chloride. Chlorine is 287. So chloride would be gain 1 electron, become 288. So they are the same. Okay, write the ionic half equation for the reaction that happens at the anode. So just now the anode, you know, the anion, which is the chlorine, the chloride ion would be attracted to it. So you can write chloride ion loses electron at the anode, okay, to become Cl. Then you know that chlorine is diatomic, so it is chlorine gas. So this one must be 2, this one must be 2, then 2Cl minus, which in this case is molten. Molten is liquid, and then you get Cl2, which is a gas, plus 2E. So this would be the answer for the ionic half equation. Describe a simple test that would confirm the identity of the elements formed at the anode. Describe a test and then confirm the identity. So this one would be the conclusion. This one is, you have to describe a test. So the elements formed at the anode is chlorine. So how do you test for chlorine? So you have to put so this one you have to put, describe a test, have to put a moist blue litmus paper, okay, into a test tube containing the gas, into a test tube containing the gas. Okay, if Cl2 is present, the litmus paper would turn red, then bleached, that means turn white. Okay, just to get this 1 mark is not easy. You have to describe a test, that means describe what you're going to use, as well as the conclusion, which is the litmus paper will turn red and bleached. Okay, let's look at D. Dilute aqueous potassium chloride can also be electrolyzed. Again, you got to list down the ions, aqueous potassium chloride. So you must have K plus, H plus, okay, because aqueous, and then Cl minus, OH minus. So describe 2 differences between the products of the electrolysis of both the dilute aqueous potassium chloride and the products of the electrolysis of molten. So what would be the differences? So if we look at the ions that will discharge, the N ion, OH ion will always discharge hydroxide ion. And then for the cation ion, which one is less reactive? Hydrogen. So these 2 will discharge. So OH ion discharge, what does it give you? What does it produce? It will produce oxygen as well as H2O. Okay, and then for hydrogen ion, it will give hydrogen gas. Yeah, so you have to describe. So that means describe 2 differences. That means for electrolysis of dilute aqueous potassium chloride, KClAq. Okay, for KClAq, H2 is formed at cathode instead of what? For molten, what will be formed at the cathode? instead of solution of potassium and molten potassium chloride, molten KCl. Okay, and then the other one is at the anode. So for this one, oxygen and water are formed at anode instead of Cl2 for molten KCl. Okay, so generally it is like that. Describe two differences. So you have to be very clear the products for each of these two electrolytes. All right, let's look at the next question. You can always pause the video for you to copy down the answer. Okay, for the next question, student investigate amount of copper that forms on the negative electrode during the electrolysis of aqueous copper to sulfate. So you have copper to sulfate, again leads down the ion. So you have Cu2 plus, because it's aqueous, you have H plus, and then OH minus, and then SO4 2 minus. What will discharge? This as well as this. Equations for the reactions that happen at the positive electrode. So at the positive electrode, which is the anode. Okay, but yeah, which is the anode, which means that the anion. Okay, carbon electrode. Okay, so this one is very simple. Your OH ion will discharge. So this one, 2H2O, O2 plus 4 electron. Okay, how about at the negative electrode? At the negative electrode, get the cathode, so the copper 2 ion will discharge. Copper 2 ion, Cu solid. Okay, this is quite straightforward. Okay, student measures the mass of the negative electrode at the start. Okay, he allows electrolysis to continue for 10 minutes. He dries the electrode, reweighs it, and then replaces the electrode to allow the electrolysis to continue for a further 10 minutes. He repeats this process until the mass of the electrode does not change. Yeah. So what general pattern is shown by the result? So this is similar to a database question. You see, for database question, you got to really analyze the data. So you have to look at, okay, of course it will keep on increasing. The mass of the electrode will get heavier and heavier. Will get more and more. The mass will increase more and more. But look at the difference. 0.41. I mean, you got to investigate the difference first. 0.24. This one is 0.63. This one is 0.43. 0.4, 0.49, 3949, correct. Yeah. So if you look at it, you can see 0.4. Okay, then drop. Okay, the amount, the mass increase actually drop. Mass increase a lot. Then after that, the mass increase of the electrode, it's become constant for every 10 minutes. Okay, what general pattern is shown? So this part, the rate of mass increase, actually it varies. It would drop, increase, drop a bit, increase. So there is no pattern here for the increase in mass. Okay, so but generally there is an increase in mass, but for the amount of increase, actually it varies. So this one you can say, as time increases, the mass of electrode increases. Okay, I'm not going to write down, so you write down. So the answer here will be, as time increases, the mass of electrode will increase. Okay, general pattern shown by the result. Okay, the student makes an error in recording one of the mass reading, which result is most likely to be an error. So there is an error somewhere. So if you look at it, see all these are the increase is 0.4. This one also. The problem is here. If the problem is here, most likely there is a mistake here. Because if let's say this one, you make it, let's say 0.4. So in order for this 0.24 to become 0.4, this one would be 4.31. Okay, correct? 4.31, correct. So if 4.31, this would be 0.4. And then if this one is 0, okay, if this one is 4.31, this one will be how much? This increase, okay, so this one will be 0.4. So this increase will be 0.78 minus, sorry. Okay, sorry, I didn't know that, just now you can't see. Okay, if this number is 4.31, this increase would be 0.4. And if let's say this number is 4.31 and this is 4.78, so the increase would be 4.78 minus 4.31, which is 0.47. So you have 0.41, 0.4, 0.47, 0.43, 0.40, 0.49, which is quite consistent. The increase in mass is very consistent. So every time it increased by 0.4, around 0.4. So the most likely, so this part, you can, so this one, most likely to be an error, which result, that means at the total time of 20 minutes. Okay, so which result is most likely? At the total time of 20 minutes, most likely the error is made. Okay, then explain your reasoning. Then you can just say the mass, okay, just follow the answer in the marking scheme. The mass increases by about 0.4 for every 10 minutes increase in total time. So at total time of 20 minutes, the mass should be about 4.3 gram. Okay, because all other times the mass increase is 0.4. Yeah, all other time. So if let's say this 4.15 is in fact 4.31, then all other mass increases would be 0.4. Alright, so this part you have to follow the marking scheme. The marking scheme is correct. It's very clear. Alright, so remember, so the thing is, when you look at this database question, you got to analyze the data. That means interpret the data, massage the data. Like in this case, you have to look at the increase. How much increase of mass is there for each time interval? Okay, the student repeats the experiment. This time he uses copper electrodes. How would you expect this result for the experiment to differ from his first experiment? So he used copper. So if you use copper, right? If you use copper, what will happen? You use copper electrode. So this one is no longer carbon electrode, it is copper electrode. What will happen? If it is copper electrode, there would be like electroplating. Okay, electroplating, both are copper. This is object to be plated, this is the plating metal. So it's a So if let's say, so this one would be like a electroplating, because electroplating both would be copper. This one is object to be sorry, not electroplating. This one is like electrolytic purification. Electrolytic purification, both will be copper. This one is the impure copper, this one is the pure copper. Okay, so if let's say both are copper, it is like electrolytic purification. So electrolytic purification, what will happen is the CO2 plus in the electrolyte will discharge at the cathode. And then for every mole of CO2 plus discharged at the cathode, the same number of mole of copper in the anode will dissolve, will ionize to form CO2 plus. Okay, so if one Cu2 plus ion discharge here, one atom, one Cu atom here will ionize to form Cu2 plus. Okay, that is what happened in the electrolytic purification. Okay, so when that happened, right, the mass increase will continue beyond 60 minutes. So the first thing is because there is a lot of copper here. Okay, because this whole electrode will ionize. Okay, so over here the mass of negative electrode will continue to increase. After 60 minutes. Will continue to increase after 60 minutes. So you have to explain why. Because like what I said just now, as Cu2 plus in the electrolyte, in CuSO4 AQ, discharges at cathode. Okay, so as Cu2 plus in the electrolyte discharges at the cathode, the Cu electrode will ionize to form Cu2 plus in the electrolyte. Okay, the Cu in Cu electrode, in the copper electrode, will ionize. Okay, will ionize to form Cu2 plus in CuSO4 AQ. Yeah. So Cu minus 2 electron to become Cu2 plus. So Cu, which is a copper electrode, Cu2 plus AQ plus 2. Okay, in the exam you have more space to write. So this will continue until your copper electrode completely ionizes. Yeah. Okay, that's why the mass increase in the negative electrode will continue after 60 minutes. Okay, let's look at the next question. The next question is aqueous sodium chloride forms hydrogen and oxygen during electrolysis. So you have oxygen and hydrogen, and electrolyte is aqueous sodium chloride. So aqueous sodium chloride, you have Na plus, H plus, OH minus, Cu minus. So what will discharge is actually hydrogen and hydroxide ions. So at the cathode, okay, the cation, H plus, you get H, so it's hydrogen. Okay, so this would be the equations at the cathode. The equation at the anode, that would be OH minus. So you get 2H2O. Okay, so this one is similar. It's similar to the, I think the first question or the second question. Okay, the gases are collected and their volumes are measured. In theory, the ratio of hydrogen to oxygen should be 2:1. That means 2 for hydrogen, oxygen is 1. Oxygen is more soluble than hydrogen in the water. This changes the ratio of gases that are collected. Why is the theoretical ratio of hydrogen to oxygen 2:1? So based on these two, why are the ratio 2:1? So remember, if you want to compare the amount of hydrogen and oxygen, okay, the volume of hydrogen and oxygen, in order to compare them fairly, the electron must be the same. The mole of electron. So this one is 2 mole, this one is 4 mole. So you have to change this to 4 mole. So if you change this to 4 mole times 2, right? So you get 2 mole of hydrogen, 1 mole of oxygen. That's why the ratio is 2:1. Yeah, so you have to explain it in that manner. So why is the theoretical ratio 2:1? So for every 4 mole, so you can say for every 4 mole of electron transfer. So it's either gain or release. So for hydrogen, there'll be gain. For oxygen, there'll be lost. Okay, for every 4 mole of electron transferred, 2 mole of H2 and 1 mole of O2 are produced. That's why it's 2:1. Explain how and why the solubility of oxygen affects the ratio of hydrogen to oxygen that is collected. So this one, so if oxygen dissolve, right? If oxygen dissolve, the volume of oxygen collected will become less. So as the oxygen become less, the mole ratio will be higher than 2:1. Yeah, because 2:1 means 2 volume of hydrogen, 1 volume of oxygen. So as the volume of oxygen decreases, then the ratio will be more than 2:1. So this one you can say as oxygen dissolve in the solution, in this case will be in the sodium chloride solution. In the solution, the volume, you relate it to the volume of oxygen, of course you have to spell out the whole thing, volume of oxygen becomes lower. Hence H2O2 ratio will be higher. Okay. Now the difference from the expected ratio. Okay, I'll have to pause. I have to record a new video because this file becomes too large already. Okay, I'll continue later. I'll see you later.